Okay, so we're going to start 6-1. Happy New Year, by the way. We're doing notes. These are notes over accumulation and change. And what this is there's three names you can call this. You can call these antiderivatives, integration, or integrals. All three of these things mean the same, and they are the opposite or the inverse of doing a derivative. So we are going to start right here. We're going to look at some stuff that we talked about before, and this says here's the graph of f prime. So this graph is the derivative over here. The function shown to the left, f of 0 is 0, f prime of 0 is 1. So in other words, right here, that's 1. Okay, that value is 1 right there. We want to know which of these things are true. Well, this is f prime, so this means f is increasing. F prime is greater than or equal to 0 on the interval from 0 to 2. So that means f is increasing the entire time there. So what that tells me is if f of 0 is 0 and we are increasing to 1, that means the graph is going up all the way till x gets to 1. That means f of 0 is not greater than f of 1 because this means f is increasing. So this is false. This one does not work. Then we want to know, is f of 2 greater than 1? Well, if you look, we've gone up from 0, 0 to some value here at 1, and then we keep going up because f prime is greater than 0. We keep going up to 2. So 2 is up higher than 1. So this one is true. And then this says f1 is greater than 3. So if you look, we're rising this much, and we are only going down a tiny bit. So in other words, your slope is 1 here, and then 0.9, and 0.8, 0.7, blah, 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 till it hits 0. But here, the slope is only about negative, maybe 0.1, negative 0.1, so it's barely going down. So we would go up more here than we would go down here. So this one is also false. So we would say that number 2 is the only one that would work on this problem. Okay, and we're also going to start talking about area. So if you look at the area under this graph, this part, and the area under this part, the area here is a lot more than the area there, which means we're rising more than we're going down. And I'm going to talk about why area is important right now. So this says a particle P moves along a straight path with a constant velocity of 2 feet per second. So this is the velocity graph. That's the graph of this function. What's the total distance? So I'm going to show you good old algebra days. Distance equals rate times time. And if we want to know the distance that thing travels from 0 to 2, the distance it travels is going to be 2 feet per second times 2 seconds, because from 0 to 2 is 2 seconds. So this seconds reduces with this seconds would tell me this graph travels, or this particle travels a total of 4 feet. So I'm going to talk to you about how this works on this thing. These are seconds over here, and these are feet per second. So if you look at this graph, we're going to learn that the distance, or the way we can get how far something is traveling in this is, if we take and we make this box down here, because we're stopping at 2, we're going 0 to 2, this length is 2 and this length is 2, we get this area here is 4 of the unit squared. So if you look at this 4 and this 4, they are the same number. So what we're going to learn in calculus is that the area under a curve to the x-axis is going to be the integral of the original problem. So in other words, again, this is 2 feet per second, just like this 2 feet per second. And we're doing area right now to get this one. So this is 2 feet per second, times 2 seconds. And again, the seconds reduce to 1. So this is 4 feet. So what we're learning is the area under a curve is the integral. And in order to get the units, we got to take the base times the height units. And that will give us what our final units is, in this case, feet. We got one more problem to do here. It says, actually 2 problems. The new pop music sensation, Sir Isaac Newton and the Newtones, have released the latest single on all their major streaming services. During its first 10 weeks of release, so we're talking 0 to 10 here, these are weeks, and you wrote it there. So these are weeks. during the first 10 weeks of release, the rate of the number downloaded per week in thousands of units is modeled by D of T. So this is downloaded per week. So this is downloads per week. Okay? And we want to know how many total downloads were purchased. So we need to get the area under this curve from here to here, from 0 to 10. So we need to make this thing into objects that we know mathematically how to find the area. So I'm gonna make one big long rectangle down here at the bottom. So the area of this rectangle is 1 times 10. This area is 10. This is a trapezoid here. This base up here is 1, 2, 3, 4. This base down here is 1, 2, 3, 4, 5, 6. And the height is from here to here is 2. So I'm going to get the area of this whole thing is going to be, well, I got that 1 times 10 in the first one, plus the area of a trapezoid is 1/2 the sum of the two bases times the height. Now let's do it like this. Let's put that half inside here. So we're going to take half the sum of the bases. So 4 plus 6 divided by 2. That's half the sum of the bases times the height of 2. That's this 2. And then we have this triangle over here, which is 1, 2, 3, 4 long here. And let's see, that goes up to 9. So this is 8 over here. So we would do plus 1/2 base times height here, 4 times 8. So this is going to be 10 plus, let's see, this 2 and this 2 reduce out, so plus 10 plus, let's see, we got 4 times 8. 4 times 8 is 32. Half of 32 is 16. So this is going to be 36. Now remember, we're taking this base times height on these. We're multiplying weeks times downloads and weeks. So this weeks will reduce with this week. So this will be a total of downloads. So the answer would be over the 10 weeks, there'd be 36 total downloads. Now that would not be the actual answer because it says up here that this is in thousands. So it would be 36,000 downloads over the 10-week period. And then we look right here. It says a particle Q moves along a straight path with the graph of the velocity of the particle Q v of t at time t changes to less. So again, this is the derivative v of t. How would one go about finding the total distance traveled over the 2 seconds? So again, we would get this problem right here, and we would want to get the area under this curve. We want this area right here. And again, this right here is 2, this is seconds right here. And did he give me that velocity? He did not. He did not say how far or what the rate was here. So this might be like feet per second or meters per second or something per second, because these seconds will not reduce out and that'll be feet. The problem is we don't know how to get the area of this curve yet. So when we're going to learn this semester how we get the area of this curve. So that's how this is different in getting the area. We don't have it in the nice geometric figure. Like up here, I did a trapezoid, a triangle, and a rectangle. That was not the only way to do this, but that was how I did it. You can make different objects. So we're going to learn how to get areas of curves this semester, and that's one of our big deals. So I hope you had a great break, and I will see you in class.